So let's look at another example of finding the distance between two different points on the coordinate plane using the distance formula. So I've rewritten the formula here that if you have two random coordinate points on the xy plane, and let's say they have x1, y1 for the coordinates for this first point and x2, y2 for the second point, then the distance between these 2 points is the square root of the difference between the x value squared plus the difference between the y value squared. So we can use this formula, and this will save us time from having to draw a picture, connect the points with a triangle, and use the Pythagorean theorem. Essentially, this formula does all of that work for us. Though it does sometimes help to do that anyways if you have time so that you can check your work. But we'll do that at the end. So for now, the main idea of using this formula is essentially just matching up what x1, y1, x2, and y2 are. So it doesn't matter which we call which, we just need to be consistent. So let's say for this coordinate point, this minus 5, we can call this one x1, and that would make this y1. So once you label one with the subscript 1, the other point, or the other value in the coordinate point, has to also have subscript 1. So that's what I mean by being consistent. And likewise, these both have to have subscript 2. So minus 9 minus 2, the minus 9, that's our x value, so that would be x2, and minus 2 will be y2. And this problem can be a little bit tricky because of all the negative signs. So we just need to be careful. So let's now use our formula. The distance between these points is the square root of the difference between the x values. So we'll put in this negative 9, that is x2, and we have to subtract our other point. And so this is where many students make mistakes, because we're subtracting whatever that point is. And in this case, that point is a negative number. So we're subtracting a negative number here, which in the end, we're going to end up just adding these together. So be very careful with your signs, because we are always subtracting. And if this is positive, then you're just subtracting a positive number. But if x1's a negative number, then you are subtracting a negative, which is the same as adding. So now we look at the y values, and y2, that is negative 2. And then we're going to subtract y1, and y1 again, that is a negative number. So put it in parentheses, we're subtracting negative 5. And so in the end, we're just going to be adding that. So now let's simplify everything. We still have our big square root, and we have minus 9 plus 5, and we'll square that. And here we have minus 2 plus 5, which we can square. So minus 9 plus 5, that is negative 4, which we'll square. And minus 2 plus 5, that is 3, which we'll square. And minus 4 times minus 4, that is a positive number. So remember, when you're squaring a number that's in parentheses, it always comes out positive. So minus 4 times minus 4, that is 16. Actually, let me do this down here. And let me make a little bit more room here. So we have the square root of 16, and 3 squared is 9. And 16 plus 9 is 25. And the square root of 25 is simply 5. So the distance between these points is 5 units. And like I mentioned, we can use the coordinate plane to actually check our work here, just to get a more visual idea of what's going on. So if we plot the 2 points, so this first one, we go left 5, so 1, 2, 3, 4, 5, and then we go down 5. So 1, 2, 3, 4, 5, so it should be right about there. And for this other point, we go left 9 and then down 2. So it should be about there. And so to find the distance between them, we would connect the points with a line. Let me make a little bit better one. And essentially at this point, just make a triangle to try to figure out what this side length is. So to make that triangle, we would go and draw a vertical line straight up towards the x-axis and stopping at the highest y value here. So that's at -2. And we would make a horizontal line starting with the leftmost x value and going to the rightmost x value. So stopping right there. And we could just label these sides. So this goes up 1, 2, 3. And this goes from -9 to -5. So that is 4 over to the right. So to find this distance d, we then would use the Pythagorean theorem. So remember, that's just a squared plus b squared is c squared, where a and b, those are the side lengths, are the legs of our right triangle. And this is a right triangle. And d is the hypotenuse, that's c. So we can call either of these a or b, but we can say 3 squared plus 4 squared is d squared. We know this is 9, this is 16, so that's 25. And to get d, we just take a square root of each side. So that d is the square root of 25, which is 5. So you get the same answer if you follow this process. But remember that the distance formula essentially does all of this for us. Since, remember, in the derivation of the distance formula, we started with two very general points and then followed this exact same logic, just being very general with x2, y2, and x1 and y1. So that's the advantage of the distance formula, is that it saves all of this work, but you can also do that work if you have time just to check that you're on the right path.